Alright, so we are going to solve systems of equations a new way. So we've got this big system here with 4 variables, 4 equations, pretty nasty looking. But what we're going to do is we're going to write it as an augmented matrix. So we've got each coefficient for each of the variables. So for example, we have x plus 2y minus z, no w's equals 2. And we have the rest of the equations represented here. So what we're going to do is we're going to get this down to reduced or echelon form so that we have each variable isolated with its solution. So we have, the first thing I see with this matrix is I see a very scalable equation in the top row because that x is, or the x's coefficient is 1, so we can easily scale that to eliminate these two. And that's exactly what I'm going to do. I'm going to add negative 2r1 to row 3, and I'm going to add negative r1 to row 4. And that's to get rid of, like I said, that's to get rid of these two coefficients here, because our goal is to get those row columns down to 0. So this is what I got from that. Top 2 rows stay the same, and here's my result from the addition. And from here, the next thing I see is that we probably want to get rid of this because we need all zeros in this column under this one. So what I'm going to do here is probably scale this equation now because this looks pretty scalable with some small coefficients. So what I'm going to do is add 6 row 2 to the bottom equation. And I'm also, while I'm at it, I just see that these are all multiples of 3. So if I want, I can just take that right down right now. So I'm going to multiply by 1/3, or divide by 3, but remember that our row operations are to multiply. So that's the language we use, so we're going to multiply by 1/3, and these are the 2 operations I'm going to change. For this matrix here, hopefully I can fit all of this on the screen. I'll have to go over here and make sure. So the top 2 rows stay the same again. We've got 1, 2, negative 1, 0, and 2. Fit all of that. Awesome. Okay. I've got 0, 1, 1, negative 2, negative 3. And then our lower 2 rows here are going to be 0, 0, 1, negative 1, negative 2. And lastly, 0, 0, negative 13. Oh, sorry, I missed a 0 there. And 39. Or negative 39, sorry. Don't miss your negatives. So the thing I see here, hopefully y'all see it too, this is pretty easily divisible by 13 or negative 13. So what we can do is multiply by 1 or negative 1/13. So that's the thing we'll do to that, or that is the operation we will do to that row in this step. And then trying to think of anything else we could do with this step. Because we need to now, once we get this down to 1, we need to now eliminate this, these 2, and these 3, right? So that we can get it down to reduced or echelon form. So I'm going to rewrite this matrix down here. Actually, no. Here's what I'll do. I'll just erase this. So hopefully you're following along. What I just did was I'm rewriting this equation after I divided everything by negative 1 or negative 13. So I multiplied everything by negative 1/13 so that I can simplify this real quick. And what I get here is just a 1 and a 3. So that was a pretty easy step. Pretty easy to change that up real quick. And so, like I said, our goals now are to eliminate these 3 variables, these 2 variables, or these 2 coefficients, and this coefficient. All these coefficients need to go away so that we get reduced or echelon form. And so, luckily, we can easily scale this equation because all we have is a z, right? So we can easily get rid of this z by simply adding, green marker here, adding R4. Hopefully you can see that. If not, I'm adding R4 to R3 in the next step. And then I'm also going to try to get rid of this one. And how I can do that is by adding 2R1, right? So I'm adding 2R1 to this row and adding, or R4. So sorry. Wow. Man, late at night. 2R4. So I'm adding 2R4 to row 2, and I'm adding R4 to row 3. I'm going to rewrite my matrix over here. Row 1 has stayed the same. So we got 1, 2, negative 1, 0, 2. And once we add 2R1, once we add 2R4 to row 2, this is what the row will look like. We've got a 0 out in front. We've got a 1, 0, and a 3. Now row 3, after we've added row 4, is going to have 0, 0, 1, 0, 1. And then lastly, our last row is going to stay the same because we didn't do anything to it. So we've got 0, 0, 0, 1, 3. We're getting close. We're getting close. All we have to do is eliminate these two coefficients and this coefficient. And we're going to do that real quick by adding, let's see, we need to get rid of this one. So we can add, what's my color for the third row? Green. Add negative row 3. And for this one, we've got a negative 1, so all we have to do is add row 3. All right, for the first time, the first row has changed. What has it changed to? We've got a 1, 2, haven't touched those yet. Then we've got a 0, right? Because we just eliminated that variable. We already had a 0 here, and now our last term in this one is a 3. And then below that, we've got a 0, 1, 0, 0, 2, 0, 0, 1, 0, 1, 0, 0, 0, 1, 3. Okay. Lots of zeros, lots of ones. But what that means, though, is that we're getting very close to isolating each variable and knowing exactly what each one is. So our last step here, after I close this matrix up, last step is to get rid of this 2. How are we going to do that? We're going to add negative R2. So finally, our augmented matrix in reduced row echelon form is going to be the normal row echelon form or reduced row echelon form with the 1s and the 0s in this pattern. And then our augmented matrix means that our solutions are going to be right here, and our solutions after we've solved everything is going to be negative 1 for x, 2 for y, 1 for z, and 3 for w. And so that means that instead of an ordered pair, instead of an ordered triple, we're going to have an ordered quadruple, I guess, and it's going to be negative 1, 2, 1, 3, and that's going to be our solution. So hopefully that wasn't too difficult. Maybe if you noticed, I followed a pattern. I tried to get rid of the bottom left variables first, and then worked my way, my left bottom variables first, and worked my way right down below. And then once we got all these to be zeros, I worked my way from the top left, or from the top right to the left. That was really confusing, so I'm definitely going to explain that in class. But hopefully this wasn't too much for you. It's all stuff we already know how to do. It just looks a little different.